So today I'm going to be doing a quick teardown of a analog multimeter. So the big difference is that's a full analog display. It's still a similar knob thing. You can turn the knob and it shows you all the different voltages. It goes up to 600 volts, has an ohms mode, so it actually has to have a battery for that. The rest of it you can use without a battery. Actually has two batteries, but we'll look more an adjustment. So if you have a calibration one, you're supposed to calibrate it. And does milliamps up to 0.12 amps. That's not very much. So definitely not designed for high current. Let's go open it up. On the back, there's four little rubber covers that hide screws. So I'm going to pop out all these screws and we can look at what's in the inside. So now all the screws have been taken out and the back piece just lifts up, and you can tell it definitely looks a lot different than digital multimeters we see today. So first thing, looking at the bottom, we see that there are two batteries. One is a standard D battery, so standard D battery. The other one here is kind of the different thing. This is a 30-volt battery, so that means it must have 20 standard cells in it, which is a lot. If I was to open this, there'd actually be like 20 little batteries in here. Something you don't see these days. Also, you have extra fuses in here, which I put somewhere else at the moment. So there's that. Then there's the main fuse here, which is a fairly standard little fuse. I think this is just holding it in. I don't know though. And then probably the most interesting thing to look at around here is this is just like a holder for a ton of resistors. So these are all 1% highly accurate resistors, like here's an 833 ohm and stuff like that, and high amp fuse. And this basically is just a switch right here. So this is just a standard rotary switch. And what the rotary switch does is when you turn it, it determines which resistor is going to be used, because here's the inlet port, or here's the connections for the actual dial, and there's a certain amount of voltage it takes to move it all the way across. So the goal of all of these resistors is to get it so that there's always the right amount of voltage no matter what setting you set it to. Very simple. The only time you actually need the batteries is if you're going to use the ohms mode, because other than that, the power is actually going to come from what you're putting in to turn the needle. Because the ohms mode actually puts in a little bit of voltage and sees how much current's going through, and then uses that to move it. I tell you, this is probably a calibration thing, or it might move the zero. No, this moves the zero on analog dials to adjust the zero. This is probably a calibration one. You have the ohms calibration one as well, which is interesting to put that one on the front. Also, it's interesting they have this high amp fuse. This looks like something like a 10 or 20 amp fuse, which seems a little bit overkill for a analog multimeter, because this is only rated for up to 0.2 amps on its highest amp rating setting. So, realistically, there's not much to look in here. I think this guy still works out, and I'm going to show a little demo about using it in a little bit. But the insides are very plain compared to today's digital ones. They're very simple. Let's go test it on some stuff. Okay, and for the first test, I have the multimeter plugged into a 5-volt power supply. This one actually just happens to come from USB. It's set to its 12-volt mode. It's interesting because a lot of the modern ones go like 2 volts, 20 volts, 200. This one just goes 3, 12, 60. And on the meter, we see that 5 volts would be around here. So if I go plug this in, it's going to be annoying. It always takes forever to plug it in. There you go. That's pretty much what I'd expect it to be at. So let's go test current now. And for the current test, I have it plugged up to a little fan that shouldn't pull very much power at all. And it's set to the highest current rating, which is 0.12 or 120 milliamps. So on the screen, on the display, it's not a screen. If I go plug it in, you see it spins up, and it says it's pulling around, well, I guess it's pulling around 60 milliamps, because that seems to be the closest. It's gone about halfway across. And if you stop it, you see it goes up to around 80 milliamps, because it pulls more power if it stops than if it's going. Let's do a quick test of the ohms function, and then we'll finish it. So now it's set on ohms mode on the times 10 setting. And how the ohms work on here is it has the times amount, and it's kind of a logarithmic scale, because it goes like 1, 2, 5, 10, 20, and then 50. And then it goes open. So if I add a resistor on, you can go, it says about 1.5 times 10, it's about a 115 ohm, I think. And it uses the bigger battery whenever it's set to the higher values. So that 30-volt battery is used when it's set to like this times 10,000 and stuff. because you need a bigger battery to get enough current to make it move. And that's why it has the 30-volt batteries. I don't know where I'd get one of those these days. So thanks for watching this kind of like teardown and test of a old analog multimeter. So please like the video if you liked it, and thanks for watching.